Hello, today we will continue doing list task. But before this easy task, let's do medium task, which is easier than easy task. All right, so 2807, insert greatest common divisor in linked list. Given the head of the linked list in which each node contains an integer value between every pair or adjacent nodes, insert a new node with a value equal to greatest common divisor of them. Return the linked list after insertion. The greatest common divisor, yes, we know what it is. So between 18 and 10, we 6. No, between 18 and 6, we insert 6. So we have 6, 6, 6. Okay. Yeah, so what I would do, like, let's first implement, try to memorize GCD algo, which is taking two numbers I and B, and what it will do, it will while B not equal. We're not going to do recursive part because it's recursive part is not good. Let's do iterative part. We say that AB equal B A model B, models B, and we return A. So then we basically what we're gonna do, our algorithm will be so for that we need two numbers, right? We need previous and next, and we have a head, but we have to return head, so we're not going to change head. So previous will be head, then excuse me, then head, right? Then next, I don't like making like naming variable next, because next is a keyword iterator in Python. So I haven't decided what would be best name for next. Maybe let's call it in NXT, right? Next equal previous next. And we have to iterate, like, let's say while previous, what we're gonna do, we're gonna call next, we're gonna insert here, we're gonna insert GCD. So if we have a link like A, B, and we want to insert A, R, B. Yes, so let's call this previous, let's call this NXT, and let's call this R. So what we're gonna do, we're gonna declare a new node, node with GCD of prev val and NXT val. It could be special cases, I believe. Like, but let's see. We will put like if to check it. No worries. And next node will be NXT, right? So we can put NXT here. And what we can do prev next equal R And that's it, and we return head. Let's run it. So none is not defined. What do you mean node? Node is not what? Oh, it's listener. Sorry. Oh yeah, I memory limit exceed. Obviously, we have to move list forward. And in my moving list forward, I mean prev equal nxt. And that's it, right? Then we do nxt. That should work, no? Yeah, I think that should work. Non-typed object has no attribute value. This is what I'm saying, like special case. So we assign next, and we can say while prev and prev next. Excellent, 99%. Beautiful. So let me copy this guy. So after we finished medium, let's go and solve harder easy. Okay. Should I check like how other people did it? No. I don't know. I mean, I did it like in 7 minutes, and it's medium. Yesterday I was doing this palindrome linked list with half reversed, like for 50 minutes, and wasn't able to finish it. So yeah, but it was good. Good task to. Yeah, I almost like 0.6. Let's see. Oh, slow next. That is next. Slow head slow. It's like saying previous. Yeah, no, it's slow is meaning it's not slow. It's meaning next and previous. Yeah, GCD. I know. Oh, they already have GCD. I didn't shouldn't. Okay, let me remove my GCD implementation. No. Yes, I already have it GCD. Oh my god, Python is great. Amazing. Yeah, pretty much. Very like obvious and straightforward solution. Okay, let's go back to beautiful palindrome linked list. So given the head of single linked list, return true if palindrome or false if otherwise. So goal of this the main idea of the solution is to first we reverse first half of the list and move both halves and check if value is not equal and check values, right? If value is not equal, return false. All right, let's go. So first, let's declare fast and slow variables pointing to head. And we need previous pointing to none for reversing. And we can say while fast and fast next. What we're gonna do, we gonna slow so the whole reversing thing is, let's do it, let's draw it how it will be done. So we have a previous, right? We have slow pointing here to the first element. Now we assign we reassign this to point to this, right? So first step. Then we assign, but we have to preserve this point. So we assign this to next, right? We reassign this to slow, to previous. Then we assign whatever is next. So this is first operation. Then we reassign this back. This is second operation. Then we reassign next here. This is third operation. And we reassign slow here. This is fourth operation. And we iterate until fast is not null. And the fifth operation, we say fast equal fast next dot next. All right, so this is what we're gonna do. As a result of this, what we're gonna have, next pointed to this side, slow pointed to this half. So after we have slow pointed to this half, then this is the first part, we reverse first and the other least. Then we move both half because we have a slow and next. We move and we compare. So we compare 2 with 2. We compare 1 in 1. And if they do not match, we return false. So this is the main idea, and let's implement this really quick. So yeah, let's close this. So like first, we will assign, we will preserve slow next. We call variable n, we say slow next preserves, and we assign slow next to previous. Then with this third operation, we move in next, slow next, slow No, next, right? Wait. We cannot move slow. We cannot move next yet. We reassign pointers. So can I say n next equals slow, then slow? Okay, I'm a little lost here. So we assign previous, then we assign slow next. Then we assign previous to slow. And we assign slow to next. And at the end, we can print, we need to print two variables, slow variable and um, next variable. Right? Oh, we have to return something, but it's okay. Let's see. So 2, perfect. Now, what we're gonna do? We're gonna do while slow. We're gonna compare slow. If slow variable not equal next variable, while we return false, and at the end we move also slow equals slow next and equal and next. It should be y slow and end, right? And we return true at the end. Okay, so this works, which is good, right? This works. This works. So odd and even works. 4 and 5 works. Why 2 and 1? Okay, 2 and 3 doesn't work. So, excuse me. Yeah, so both on 0. I don't know if this is 0, is that 0? Okay, if there are 2, we can say if head next if not head next, meaning just one element, we return true. If not head next meaning 3 elements, right? So this is 1 element, this is 2 elements. We return head val equal head next val. What else? Um, if there is a tree, should I check if there is a tree? Really? Why am I 0? Oh, let's print. I can print ID of this slow and well. Can I print ID to see if they're pointing on the same element? Oh, let's create function def print node. We accept node and we print something like maybe and well and like ID and so here I can print node slow and print node left. What I want to see, like, are we standing on the same? Object has net attribute val. Okay, so it's int. Oh yeah, I have to remember, obviously. What I want to see, like, are we standing here on the same? Yes, we are standing on the same 0. So now what I need to see, I have to, because I'm standing here, I have to move back 1. Because for, how this is working? How, like, why this is working? Oh, because it's 5. I still don't understand how it's working, honestly. Okay, and this is not working. Obviously for 3 only not working. So can I say, if this is 3, meaning next, next. So I can compare head well and head next, next well. It's kind of like, yeah, it's working. Okay, let's submit it and see what happens. I mean, we may have a different thing, but if it's working, I welcome the solution. Yeah, so this is not working. 32 of 93 test cases, and this one is not working because we are standing on same one. So head, next, next, next is 0. Did I put too much next? 33. Use this case. Run. No, it's not. It's not 33. Not here. Oh, here is 33 because truly it's 3. Okay, this is 5 is working. 4 is working amazingly. But this 4 is not working. Why? Because it should return false. But it's not returning false. Is it? No. Okay, so I assume it's not working correctly. We are standing on the same one, but we don't have to. We don't have to stay on the same one. we have to stay on 1 and 2. And we are staying on the same one, probably this one. So I need to move one, I need to move one iteration forward, right? So can I say if fast and not fast next, then slow equal slow next. I'm standing on different tools, but now this is not working. Okay, this is not working. Why? Because here is working. I'm wait. So slow will be pointing on. Slow should be pointing backwards. So we have slow 2. 1, 1. Oh, okay. Should I move n? I should move n, not slow. Why is this false? Suddenly, is it like All right, so let's get back. Sorry about that little break. Let's get back to our tasks. So yeah, I think let's build a printing function to print list, because it's not only, for example, we have both 2 and 2, right? But which one? Do we have like this pointing on 2 to 1, or and 2 to 1? But they should be the same. Why are not the same? And so on. To answer this question, I don't know how to answer this question. Honestly, obviously, this thing is not working. If I command this, I still have a problem with the list, right? Yeah, I can do pass for one. I mean, but what is the difference? Why this, for example, the question is why this is working and this is not, and because something wrong with my code and it's always returned true, meaning it's not comparing, it's not working how it's supposed to do. I think it's working, but it's not. And yeah, let's build print function and find out. So we assign like h1 equal h1 equal h, while h1 we create some kind of string result. Real quick, what we need to assign here a thing. Let's print node here, and we return string, and we assign h1 equal h1 right. So instead of printing just the values like we did here, let's print entire thing. And see how it's actually working. No, it's not working. Oh, okay, so this is I don't know. Okay, what is this? Two is the same. While h1 print h1. And instead of we just print right at the end, what is going on? Yeah, it's good that nobody watching it. Okay. So okay, so now we have um, let's take it slow. It's supposed to move forward. Can I say forward list and no slow. Wait, I forgot. Slow is backward. So backward and forward. I just print it. Okay, so backward list is 1, 2, 1. Forward list is the same. 1, 2, 1. No, something wrong. We basically assigning this to. So they point in the same direction, same object. Everything is the same. So my question is, 1, 2, 1. 1, 2, 1. So this is like still moving forward. So it's a forward link. Is it path? Why am not assigning here fast? Fast next. Next. So here forward is this one, which is one on this. I need to move another notch. This is false. This is added to me. So and this is also one. So we assign slow to previous. Then we move previous to slow. Wait, there is something wrong with this one. It's not moving. So normally we just assign slow equals slow next for moving. So we assign n as slow next, then we assign slow next previous. Yeah. Okay, let's do reverse linked list again. Reverse. Yep, this one with code reverse linked list. Yep, we did it yesterday. Let's do it right now. So we assign we need previous, we need current, and we need next, NXT. And we have none, we have add, and we have none. So while current, we're gonna assign current next to previous. But before that, we store current next into NXT. Then we assign current next to previous, and after that, we assign current to next. And we return head. That's it. Name n is not defined. NXT. Next. Huh. That's a problem, see? It's not... Okay, so if this is empty, It is an empty. This is not working because I cannot return head. I have to return. Oh, current will be empty. I have to return tree. Because I'm not reassigning tree here. Tree will be current. Okay, so let's do it again. Yeah, I have a feeling like I need to do reverse like 50 times until I finally got it. So for reverse, let's do it again. We assign previous to none. Then we assign current to previous. Oh, let's write it down. Current next is previous. Then we NXT is equal current next. So this line we store this link. So we point in NXT here. Then current next we assign to previous. Then we move current to NXT. This one. Oh, we need to assign previous to current before assigning current to NXT. Gotcha. Yep. Yeah, maybe third time is the charm. Let's see why I made a mistake here. So NXT equal current next, and current next equal previous. The previous equal current, and then current equal next. Yeah, it should work. But I have a feeling that for here, for example, I need to move one more notch after finishing this. So let's say while stop, stop. Yeah. How do I say? Like when we finish this, so I can say continue equal. Here I can say equal continue equal true. Let's say while continue. Still the same, right? But now I can say while fast. Yeah, that's the problem. The same. And say else fast equal fast next. Yeah. And it has no effect whatsoever. Okay, so let's do this. Let's just do one more rotation. All right, let's take a break and continue after this on part two after the break. Thank you.